This is Jacob's Algebra, Chapter 12, Lesson 2, Part 2. We were working through problem number 6. The instructions say write each of the following in simple radical form. And we did parts A and C. So now we're just going to do two more parts from number 6. So let's look at part F. Part F is the square root of 396. Now I can tell by looking at this pretty easily that 9 is a factor, because when you add all the digits of a number together, if that sum is a multiple of 9, then 9 is a factor of the number. So I know that 9 is a factor, and when I punch that into a calculator, 396 divided by 9 is 44. So I know that 396 is 9 times 44. But when you look at 44, 44 is 4 times 11. So really what I have here is 9 times 4 times 11. So what I can do is look at this and say, oh, the square root of 9 is 3. The square root of 4 is 2. And then I can't do anything with the 11, so it stays in the square root. So the answer to square root of 396 is 6 square root 11. Okay, let's do one more part from number 6. That's part H. Part H is the square root of 5,400. Now, you can see right away that this is going to be 54 times 100, and 100 is a square number. But you can also see that 54 is a multiple of 9. So we can break 54 into 9 times 6, and then we have the 100. So when I pull the 9 out, square root of 9 is 3, square root of 100 is 10, and then my 6 is just left in the square root. 3 times 10 is 30. So the square root of 5,400 is 30 square root 6. So that was number 6. And it's just like number 13 that I assigned for homework. I did not assign number 14 for homework because it was a look up the numbers in the table and just write down the answers problem. So I didn't find that very useful. So we're going to skip down and look at problem number 8 instead. Number 8 says, what expression should replace the shaded area in each of the following equations to make it true? Assume that x is greater than 0. So let's do a couple of parts. This is number 8. It is just like number 15 that I assigned as homework. So number 8, we have part A, we have square root of 49x is equal to something times the square root of x. Well, we can see our x is here in the square root. What we're missing is this 49. So to take the 49 out of the square root, we have to square root it. The square root of 49 is 7. So our answer is 7 square root x. Let's skip down to part C. Part C, we have the square root of 2x cubed times 2x cubed. And that equals blank. Okay, if you look at this 2x cubed times 2x cubed, that means that what we have is the quantity 2x cubed, all of it squared. And when you take the square root of a square, you end up with your original number. So what we have is 2x cubed. The last one we're going to do for number 8 is part E. Part E is the square root of x to the 5th. Now, anytime you have something with a power inside of the square root, what you can do is pull out the even part. The biggest even number in 5 is 4. So x to the 4th times x, because remember, when you are multiplying numbers with exponents, you add the exponents. The square root of x to the 4th is x squared. So this is x squared times the square root of x. The other way you could look at this is x to the 5th to the 1/2 power, because remember, square root is to the half power. So that is the same as x to the 5/2. And x to the 5/2, 5/2 is 2.5. So that means x squared times x to the half, and that is x squared times the square root of x. Just to give you another way of looking at this problem. So that was number 8, which is just like number 15 that I assigned for homework. Let's look now at number 9. Number 9 is just like 16. It says, where possible, express each of the following as a monomial. Assume x is greater than 0. Anytime it says where possible, that means you run into the possibility of it not being possible. So let's look at part A. we have the square root of 9x squared. The square root of 9 is 3. The square root of x squared is x. 3x is a monomial. One thing that's important here is to remember what a monomial is. A monomial is anything of the form ax to the n, where n is a non-negative integer. N can be 0, 1, 2, 3, 4, 5, it can be 0 or any positive integer. It cannot be a fraction. It cannot be a negative number. So let's look now at part B. We have the square root of x to the 36th. Remember, square root is like a half power. When you raise a power to a power, you multiply the powers. 36 times a half is 18, so this is x to the 18th. Okay, part C, we have the square root of 36x. Well, we can take the 36 out of the square root. The square root of 36 is 6. And then x is still stuck in the square root. That means we cannot write this as a monomial. This is not possible, because x to the 1/2 or square root of x is not monomial form. We have to have x to an integral power. Let's look at part D. We have the square root of 36x, and then the whole thing is squared. Well, when you square a square root, those operations undo each other, so we end up with 36x, which is a monomial. So that was number 9. It's just like number 16 that was assigned for homework. Now let's look at number 10, the last problem. It's just like number 17. It says write each of the following either as a monomial or in simple radical form. That means all of these parts are going to be possible. You'll write it as a monomial or in radical form. So part A, we have the square root of 64x. The square root of 64 is 8, but our x is left in our radical. So that is all that we can do here. Look at part C. We have the square root of x to the 7th. Remember that x to the 7th can be written as x to the 6th times x. The square root of x to the 6th is x cubed, and then we still have an x under the radical. Part D, we have the square root of 40x squared. Okay, 40 is not a square number, but we can break it into something that has a square number. 40 can be written as 4 times 10, and 4 is a square number. X squared is also a square number. So the square root of 4 is 2. The square root of x squared is x. And then we have a 10 that's left behind in the radical. Okay, the last one we're going to do is part F. Square root of 18x to the 18th. 18 can be rewritten as 9 times 2. And then x to the 18th is already a square number. So 9 is a square number, and x to the 18th is a square number. Square root of 9 is 3. Square root of x to the 18th is x to the 9th. And then we still have a 2 sitting under our radical. So that was number 10. It's just like number 17 that I assigned for homework.